We solved systems of equations. The first day we did it graphically. Okay, off your phones. It's all about me now. Okay, so where the two lines crossed, right? That was the intersection point. Yesterday we did the substitution. Today we're going to do a method called elimination. And to eliminate, if you ask to go to the bathroom, I'm going to punch you. Then sharpen it. No. So, no. Somewhere on the desk. All right. You have to have two things. Shh. Two things. You have to have a plus and a minus, and you have to have the same coefficient. So if I look at these two equations right here, first of all, look, does one of them have a plus and a minus? The y does, right? Is the number in front of the y the same? It's a 1, right? So if these are the same and one is plus and minus, we can just add straight down. And if I do that, I get 2x plus 1x is 3x. The y's cancel, and this is 9. So I get x is 3. So it doesn't matter, but you have to use one of your original equations to find y. Okay? You can't use these. You have to use one of the top two. So I'm going to use the bottom one. I get positive 7. So my intersection point is 3 and 7, right? It's still an intersection point. Yeah. So if we look at number 2 now, these are not lined up to start with. So I'm going to rewrite the top equation. And I'm going to move this 4x over to this side. And I'm going to line them up. So I'm going to get 4x plus 6y equals 9. So first of all, pick one of them, and it doesn't matter whether we do x or y. Which one should we get rid of? All right, if we're getting rid of the x, if I'm getting rid of the x, I need one to be a positive and one to be a negative, and I need it to be the same number. So if this is a positive 4, I need the top one to be a negative 4. So what would I multiply the top by to get negative? I'll multiply by negative 2. So part of the reason you're not getting it is there's lots of you talking in between. Okay? So I need this number and this number to be the same. So if this is a 4, what do I have to multiply the 2 by to make it a 4? 2. And I need one to be positive and one to be negative. So if this is positive, this is going to be negative. So when I multiply through, this is what I get. And then look what cancels. This cancels and this cancels, so I have 0 equals 1. Is that true? No. So this is no solution. What are the two things you have to have? I had a positive and a negative. One of each, same number. One of each, same number, over and over. So, which one do I want to get rid of here? The y. And why did you choose the y? That is, they already have the same number, right? So what's the only other thing I have to do? One of them has to be negative. Does it matter if I do the top or the bottom? It doesn't. So if I multiply this by -1, the top stays the same. See, these are both positive, and I need one of each. So I had to change one of them to a negative. So what cancels? These cancel. I get minus 3x equals 6. So I have x is -2. And then I'm going to take my -2, and I have to plug it back in one of the original equations. And it doesn't matter which one. You're going to get the same answer either way. But it has to be an original equation. So if I take my -2 and put it here, I have 5 times -2 plus 3y equals -19. So it gives me y is a -3. So what's my point of intersection then? Correct, and that's your solution. Very good. So which would you like to get rid of on the next one? Top what? When you're getting rid of something, it's either x or y. You have to pick one. It's not a top or a bottom. All right. So which one? All right. If I'm getting rid of y, so this is a +2. What do I need this one to be? -2. So I'm going to multiply this -2. So I get x is -2. And once I get x is -2, which is the easier one to check to find the y? Right, because that's the easier. So I have -2 plus y equals -2. So my intersection is -2, 0. Thank you. This is not hard. None of these are hard. The homework is exactly what we're doing. All right, the Ferris family paid $180 for 2 adult tickets and 3 child tickets. So if I have 2 adult tickets and 3 child tickets, and I pay $180. The Smith family paid $105 for an adult ticket and 2 children tickets. So learning what we just learned, I want to eliminate, well, first of all, I'm going to eliminate one of them, but second of all, what's the question? What are they asking for? So I want to end up with the price of a child ticket, right? So I need my C. That's what I'm looking for. So if I'm looking for C, which variable do I want to get rid of? We want to get rid of the A, right? Because I need to figure out what the C equals. So if I'm going to get rid of my A, if this is a +2, what am I multiplying the bottom by? -2. So the child ticket is $30. Number 6, last one. Aiden has a total of 20 nickels and quarters. So we're going to have nickels plus quarters equals 20. So the value of the coins is $4. So if the value is $4, how much is a nickel worth? 5 cents. So how do I write that? That's 50. 0.05 gives us a nickel. And the quarter? So it would be 0.25, right? So the question asks how many nickels and quarters. So I need both of them this time. So which one should we start by eliminating? If I eliminate my nickels, I'm going to get negative 0.05n I don't think so. So I multiplied across the top by negative 0.05. So when I add these together, the nickels cancel out. It tells me I have 15 quarters. So if I have 15 quarters, how many nickels do I have? Because there's 20 altogether, right? So you have 5 nickels. Cakewalk.